Today is Tuesday, April 27th. Please study your flashcards. We're going to be focusing on two different things today. We're going to be reviewing the area of rectangles. That's Chapter 9, Lesson 5. Please open your books and actually refer back to the information in that chapter to help you. So this information is reminding you what the word area means. It's the number of square units inside a shape. There are examples for you. There is a video explaining this. Now, this gets only slightly trickier. All you have to do is multiply the length times the width for the area of rectangles, but it gets slightly trickier when you have decimals and fractions to deal with. So there are two videos below these two pictures to show you how to do those two things. Please take the time to actually click on those. And then there's information about how to find the area of squares. The formula looks a little bit different, but it's still length times width. It just so happens that the length and the width are the same length, so you can write that as area is equal to s squared. Now, then we learned about area of parallellograms, which is essentially length times width again. However, and again, you can look at Chapter 9, Lesson 6, and these are the page numbers for more support. You can't exactly take one side and multiply by the other side because of the slantiness of some parallelograms. So this particular video shows you why, how we can come up with the area of parallelogram. So please listen to this. Okay, so here is a model of a parallelogram. We're going to show how knowing that rectangles are parallelograms can help us find the area of all parallelograms. Now, the first thing we're going to do, I'm going to click this animation, and we're going to show how a rectangle is related to a parallelogram. So we see that a congruent parallelogram was taken from the first one and then broken into two pieces. When you move those pieces around like a jigsaw puzzle, it actually creates a rectangle that has the exact same area. Okay, so these two figures have the same area. And what happened is you drew a line from one of the vertices to the base of the bottom of the parallelogram, and then cut along that line, moved that figure over to the other side to make the new rectangle. That is why we call this base times height. The height is the vertex. The line from the vertex at the top to the bottom base is called the height, and then you multiply by the base. And the height has to be at a has to be perpendicular to the base. So that's how you figure out what the base is and what the height is. Okay. So here are some more examples. The formula is not length times width anymore. It's area is equal to base times height. And you can see this height. This is where the perpendicular is. Now you'll notice that this has the base number at the bottom, but that's because it's congruent. Parallelograms, opposite sides are congruent. So 7 times this base is the same as times this. There are two bases in a parallelogram. And same thing over here. So you have the drop down height can be off to the side. That height is perpendicular to this bottom base, and you can just multiply the base times the height to find that area. Okay. Sometimes there are two-step problems in which you find the area for something larger, the area for something smaller, and you have to subtract to figure out what the shaded areas, what the shaded area is. Please click on this video to watch if you have no idea how to do that. Now, the only tricky thing really that may come up for some of us, aside from having to do computation with decimals and fractions, which still is challenging for some of us, is the missing dimensions problems. So you're going to be given the area and maybe the base, but you're not given the height, or you're given the area and you're given the height but not the base, and you have to figure out what the missing number is, and that's Basically solving for the algebra problems we've been doing for months now. So shouldn't be tricky, but sometimes it is. This example here, just click on this video and you can see how to solve this one. And it's really up to you to look for help. The Canvas course has help all over the place if you just choose to take the time. And also open up your textbook. There's also examples in there that will also support you as well. And come to Math Help. Ask me a question. I'll help you too. We're going to do some practicing right now. Okay, so let's try one of these practice problems together. Karen has a square vegetable garden that has a side length of 21 and 5/10 feet. She increases the length of each of the sides of her square garden by 3 feet. Then, by how many square feet does she increase the area of her garden? All right, so a couple things are going on here. So this is going to be more than a one-step problem, but we are not going to give up or start weeping softly. We're going to figure this out. Ultimately, we are going to be asked, we're looking for how many square feet the increase in area is, but to do that we have to figure out what the original area is to start with. So what are we going to do? Well, the original side was 21 and 5/10. So in order to figure out the area of a square garden, the formula is going to be area is equal to s squared, or we can think length times width, but the length and width are exactly the same length. So let's go ahead and multiply 21 and 5/10 by 21 and 5/10. And please don't give up and use a calculator. I want you to actually, these numbers are very easy to multiply, 2, 1, and 5. So do your best and do it correctly the long way with your brain. Okay, so if you said the original area of our garden was 462 and 25 hundredths feet, you are correct. And how did I know to put the decimal 2 spaces over? Well, there was 2 spaces worth of decimal places in the 2 factors at the top. Okay, so now we have to calculate the new area of the garden. The important piece of information is that each side was increased by 3 feet. So what is 21 and 5/10 plus 3? Answer that for me, please. Very good. It is 24 and 5/10. So we are now going to be multiplying 24 and 5/10, again, without crying or giving up and using a calculator. We're going to multiply those two numbers together. Go ahead and do that for me now, please. Okay, so the new area of the garden is 625 hundredths. And the reason why it's 25 hundredths is there are 2 decimal place values in the 2 factors, so we move the decimal twice to the left. Okay, so how do we figure out what the change is? So what operation are we going to do? Add, subtract, multiply, or divide? Answer that for me, please. Very good. If you said subtract, you're correct. We're going to take the new larger area of the garden and we're going to subtract the old area of the garden. And we're going to find the difference and the change in the size of the garden. And the important thing to remember is you want to make sure that you always line up the decimals when you are subtracting and when you're adding. When you multiply, it doesn't really matter. You deal with the decimals later, but when you add and subtract, you have to make sure that all the decimals are lined up. So go ahead and solve this for me, please. Okay, so if you said 138 feet, you are correct because 138 and 0 100ths is the same as 138. That is the increase in the area. Now we're going to practice one more problem together involving area of a parallelogram. Okay, Tara and Veronica are in charge of making a banner for the volleyball game this Saturday. How much poster paper will they need for a parallelogram-shaped banner with the height of 3 1/2 feet and the base of 6 1/4 feet? Okay. So the formula, if we're going to find the area of a parallelogram, is base times height. So all we have to do is multiply 3 1/2 times 6 1/4. Okay. The very first thing we have to do is change both of these mixed numbers into improper fractions. What improper fraction will be equivalent to 3 and 1/2? Answer that for me, please. Very good. That's going to be 7 and 1/2. 7/2, excuse me, because 3 wholes times 2 pieces, 3 times 2 is 6 plus 1 is 7. 7/2 would be the same as 3 whole 2-piece segments plus 1 more. And we're going to multiply that by what is equivalent to 6 and 1/4 as an improper fraction. Answer that, please. Very good. That's going to be 25/4, because 6 times 4 is 24 plus 1 is 25. All right. Now what we need to do is to go ahead and multiply these two things together. So please do that. Let's start by multiplying the numerators. And the reason why we're not going to simplify is we can't simplify these factors first. So what is 7 times 25? Please answer that. The numerator will be 175. And what is the denominator going to be? What is 2 times 4? Answer that, please. Very good. That answer is 8. We're not done, though, because we can't leave this as an improper fraction. We have to change it back into a mixed number. So we are going to divide 175 by the denominator, which is 8. And if this does not divide evenly, please make sure that you show the remainder as a fraction, not a decimal, and not as remainder blah, blah, blah. Go ahead and solve this for me, please. To set this up, we are going to put the numerator inside the division symbol, and we're going to divide by the denominator. The area of this parallelogram will be 21, and since the remainder was 7, we're going to put 7 as the numerator and 8 as the denominator. So the answer is 21 and 7/8 feet, square feet, is going to be the area. All right. I need you to answer the question, what is something important to remember about finding the area of rectangles and parallelograms? This needs to be at least one complete sentence, and it needs to be something specific. I appreciate your thoughtful response. Please come to math help if you need help. Please come to math class and ask questions, participate. Thank you.